So my name is Geri Jennings, and I work for CyberArk, which is a company who has a big office in Newton, but I work from here in Western Mass. And we work on securing privileged access for applications in dynamic environments, which a lot of times just means secrets. But today I'm not going to talk very much about that, though I couldn't help but slide something about secrets in here, so enjoy that later. What I am going to talk about is Kubernetes. So what is Kubernetes and why should I care? This is a question that I had some trouble answering when I first started thinking about it around 2016. I was working for a company that provided a SaaS product. We were using Google Cloud Platform and deploying our application to VMs. And I knew something about Docker. And I liked the idea of being able to containerize our dev and test environments, but I didn't know what I would do once it got to production. I didn't know how that worked. And I had some vague sense that Kubernetes might be an answer, but I didn't know enough about it to understand what to do with it. Since then, at my new role, I end up doing a lot of work around Kubernetes. You know, we build a product that we want people to use in Kubernetes, and so we have to integrate with that space. So that's the perspective that I'm coming from as I start this talk. Let's just get this right out of the way at the beginning. It's pronounced Kubernetes. The CLI that we're going to use to do a lot of the stuff to interact with our Kubernetes cluster is pronounced kube control. And they have some stringent recommendations in the style guide for how you abbreviate it. Naturally, because there are 8 letters in Kubernetes, we abbreviate it K8S. But moving on to the meat of the talk. Really what I'm going to talk about for a lot of this is containers. Only, not this kind of container. Really more this kind of container, which is, if you don't recognize it, the logo for Docker. Docker came out in around 2014 and emerged as the early standard for containers. Docker defined a standard for building, storing, and sharing images. And it provided a system and a way for running containers based on those images. It's not the only container runtime now. And in fact, in the past year, there's been a lot of action in the space of container runtimes. And Kubernetes itself actually allows you to plug in a variety of different container runtimes. Today, we're going to be using a local Kubernetes tool called Minikube. And it also, I learned this week, allows you to try out different container runtimes. So that might be an interesting experiment if you're curious about this. When you're running Docker, as opposed to deploying your app to a VM, there's some slight differences in how it's architected. So usually when you're using a virtual machine, you have a host operating system, and then you have the virtual machine sitting on top of a hypervisor there. In Docker, it's primarily, if you're running it on Linux, you have the Docker engine, and the containers are running on top of the Docker engine. Everybody always draws them this way as boxes. I saw a really interesting talk this week that tried to throw that idea out the window because really they're just processes running on your system. But there are mechanisms in place that isolate them, and so that's where a lot of the benefits come in. So let's say I want to define a container so that I can run it. Well, that's not exactly how it works. You don't define the container, you define the image. An image is, in essence, a snapshot of a container, although it's not quite exactly the same as if you take a running container and you take a snapshot in time. It's more like what you want the container to be to start. Once you have an image, you run it to get the container. And to define an image with Docker, you write a Dockerfile. So this is an example Dockerfile that I am using to run some tests for a Golang app that I have. So it starts out by defining the base image, which is a Golang provided base image. I copy in the dependency information and install the dependencies. I copy in the rest of my code, and I set the entry point to be go test-b. And I can pass additional parameters to that go test command when I run the container. So when I want to run my test suite in CI, I have my CI system run Docker build to build the image. And then I Docker run the container to run that test suite. So I can, in this case, I'm just running the unit tests that are in the package directory. There's a lot of flexibility because I've set it up to be able to pass in parameters. So all that's good. Some of it might even be very familiar to you already if you have already been playing around with Docker. But what are the benefits of using containers? So when you have containerized environments, you can provide a consistent development environment for everyone. So I don't have to worry about the Ruby version that my application uses because I'm spinning it up in a Docker container, and that Docker container specifies what Ruby version it is. So I don't have to worry about changing which version I'm using locally. It's just taken care of automatically for me in the Docker container. My test environment is going to be consistent with my local dev environment. So I know if I'm working on it locally and it works, and then I push it up to Jenkins or whatever, and it runs the tests, I can expect that it's going to work the same there. And then ultimately, if I'm taking this same artifact and I'm deploying it in production, I should expect that it's going to work the same way. But how do we get there? How do we take this container and get it into a production environment so that it's going to work the same? And that's what we're going to talk about next. So if you start with a development environment that uses containers, and you're running containers in your test environment, why wouldn't your production environment also use containers? If you do that, you have it in all three places, then you can keep your production environment consistent with dev and test, and that's going to lead to better predictability and reliability, at least in theory. That, at least in theory, probably ends up being pretty important when you're doing it in production, but we won't get too much into that today. So let's ship it. Let's do it. Let's deploy some containers. So we want to do it in our production environment, and the environment that we have in production needs to understand how to run the containers. We want something that's going to be able to orchestrate them so that it's easy to deploy them and it's easy to scale them as needed. Once we have all of these containers deployed, they're probably going to have to talk to each other. So how do we set up the networking for that? How do we make sure that all of the containers in our system can also interact with our database that we have set up elsewhere? And ideally, we probably want to have some way of having persistent storage within that system and monitoring so that when issues happen, we know how to handle that. And that's where Kubernetes comes in. So Kubernetes is an orchestration system, and it manages this stuff for you. So at this point, I'd like to kind of look at what in practice it looks like to deploy an app to Kubernetes. And so to do that, I'm going to take an existing containerized application that I have. It's defined in a Docker image. And I'm going to run Minikube, which is a local Kubernetes cluster on my machine. And I'll take advantage of the kube control CLI. So this is the application that I'm going to use. It's actually the same one that I did at Nerd Summit last year. It's PHP. And it is an application that I have running in Docker. It needs 3 secret values to access the Twitter and Google APIs. It has an optional Postgres backend, but because I don't want to just keep throwing secrets at this today, I'm going to leave that off for the work that we do next. The Dockerfile for that application starts from the PHP base image, installs some things that I'm going to need there, like the Postgres client, which I'm actually not even going to use this time. And it installs Composer, copies my code into var www HTML, and then it installs my dependencies. So we want to think about how to translate that application that I'm already comfortable running in Docker to a Kubernetes cluster. And before I can really do that, I need to understand some basic Kubernetes concepts. So this is what we're going to think of inside my Kubernetes cluster. In the cluster, a pod is the smallest unit you can deploy. And a pod can contain one or more containers, and they're usually tightly related. You think about the containers that are in a pod correspond to a microservice that you have. So if you have more than one container, it's usually something like one instance of an application running in this container, and then this container might be something like what's called a sidecar container, so a container running alongside your application that can provide a service like taking the logs and sending them to a log aggregator or something like that. So you can think about what's in the pod as an instance of a microservice. Containers within the pod can share volumes. So for instance, if I'm working with a log aggregator sidecar, I might have my container write all of its logs to this shared volume so that my log aggregator application can read those files in this shared volume and send them off to wherever they're supposed to go. Containers within the pod can communicate over localhost. So, for example, there's a project that I work on that is a sidecar proxy, and my application container connects to the proxy via localhost. So that's convenient in a lot of cases. And if you want to scale your application, you do so by running multiple pods. And that's called replication. And the thing that manages your application scaling is called a controller. So you can define a controller when you deploy your application, specify how many replicas of your application you want to have, and the controller will ensure that your application keeps that number of replicas available. For my application, it's going to look like this. I'm just deploying the single application container to a pod. I don't need a sidecar. There's no other containers that I need. If I were to add in Postgres and also deploy that and connect my application to it, I would run that in a separate pod. And a lot of people will tell you, you probably still don't want to consider really running Postgres in Kubernetes because Kubernetes works better with stateless applications. They do have concepts like a stateful set where you can deploy stateful applications, but it's on the newer side still. So for now, I'm just going to focus on this one application container running in a pod, and I'm not even going to worry about scaling it, although I could specify more than one pod be spun up. So the replication controller that I'm going to use is called a deployment, and I'm just going to run a single instance of my application. But I'm also going to have to manage that the application needs those 3 secrets. So there's a few different ways that I can manage getting secrets into an application in Kubernetes. And I'm going to list out the options from bad to best. So you can build them into your app image. That's bad. Don't do that. Why is that bad? Because then if somebody else gets access to your app image, they have access to your secrets. You can store them in Kubernetes secrets, which is a native component of Kubernetes, but they are unencrypted. They're base 64 encoded, but anybody can decrypt them. Kubernetes doesn't come with encryption by default. If you want to use encryption for Kubernetes secrets, you have to install it. So that's the next OK option, which is install encryption into your cluster and use encrypted Kubernetes secrets. And maybe by virtue of working for a company that builds a vault, I will say the best option is to store them in a vault that works well in Kubernetes, where works well is like loosely defined as is able to inject secrets into applications that need them in Kubernetes. But since this is a demo, and I'm using Minikube, which is just local anyway, I'm just going to use the unencrypted Kubernetes secrets. So we'll walk through that in a minute. And that's my reaction to the fact that I'm going to do that, but okay. So in my, I wonder if I can turn this light off, do you know? It's kind of hard to see. So in my GitHub, in the application that I shared, thank you, last Nerd Summit, hopefully the gray is okay to see, but the important thing is what's outside the gray. I'll kind of walk through it anyway. I added a script called Minikube instructions. So if you wanted to check this out later, you could clone the repository to your machine and try this out yourself. But basically it's stepping through what we're going to do today. I already did Minikube start because it takes a minute, and I didn't want to have to make you sit here and watch me. I'm going to build my Docker image for my application before I deploy it, and I want to make sure it's available in the Minikube Docker daemon. So I have to set the Docker environment for Minikube before I can do that, so I'm going to do that right now. And then once I do that, I can call my build script that builds the Twitter search Docker image. Of course, you have to sit and watch this now. Seems like a good time for a drink of water. So right now it's pulling the PHP Docker image, and then it's going to do all the things that we saw in the Dockerfile. It's going to install the tools that we need, and then copy my code in, and use Composer to install the dependencies. So it's doing that part now. Once this process is done, there will be a Docker image for my application available in Minikube, so I can deploy it. So we can look at the next steps while that's running. So I'm going to create a Kubernetes namespace to deploy my application in. You don't have to do this. Minikube has a default namespace, and the recommendation from Kubernetes is if you have less than 10 or so people working on a team, there's nothing really wrong with all using the same namespace. But as you grow in size, namespaces are a useful way to partition whose apps are where. And I also kind of find it nice if you think about logically organizing your applications. It might make sense for a bunch of microservices to go in one namespace if they're all related, but if I have an unrelated microservice, I might choose to put it in a different namespace just so that logically my applications are organized in Kubernetes sort of the way that I think about them logically being organized. So that's my next command, is to create the namespace. And once I've created the namespace, I'm going to, in that namespace, create a secret that's type generic. So there's other kinds of secrets, but I just want a generic one. I'm going to call it Twitter Search Secrets. And it's going to be three things. It's going to be the Twitter API key, the Twitter API secret, and the Google API key. I use a tool called Summon that takes secrets from my OS X keyring and injects them into a process environment. So I copied this into a bash script, and I'm just going to wrap that bash script with Summon to make sure the secrets get injected the right way. So I can see that the secrets were created.
As environment variables?
No, so I used Summon to pass the environment variables to this script, which is just calling this command. So it's taking the environment variables and loading them into the Kubernetes secrets values. So with anything that you load, I can get the namespaces, and I see the namespace that I created. I can get the secrets in the Twitter search namespace, and I can see that it's been loaded there. And we're going to see this pattern as we continue on. So now we've created a namespace for the application to be deployed in. We've created secrets in that namespace. So now we need to prepare the application manifest. So I'm going to go back to here. Stop judging me. So I'm going to go through the pieces of the manifest on the next 3 slides. This first part is where I define the deployment replication controller that is going to make sure that there's one replica of my application always up. So I'm defining a deployment, I'm naming it Twitter search deployment, and I'm associating it with the label Twitter search. Everything under this template is called the pod template. The pod template defines the label for the pod, which matches the label that I have up there, and it defines the containers that are going to be in the pod. So I have one container, its name is Twitter search, that's the name I'm giving it. It's based on the Twitter search image, that's the name of the image that I built. It exposes locally to the Kubernetes node the port 80. And in this selector field, I'm defining how the deployment finds the containers or the pods that it's going to manage, and it's based again on the same Twitter search label. So that is the part of the manifest that's related to the deployment replication controller and the container that's going to be in that pod. In that container, I want to make sure it has the environment it's going to need to connect to the Twitter API and to the Google Maps API, in case I want to use them. So I want to add a section for the environment that sets the environment variables that are defined at each name and gives them the values that come from the secrets. So I have to refer to the secret and the specific key value that needs to be loaded into that secret. So you can see, this is the command that I ran to generate the secrets, and I'm adding each one as an environment variable in the manifest. Makes sense so far?
So the container now has the same 3 environment variables that you have.
Yep, when I run it locally. The last bit is, so far I've only exposed the application internally to the cluster. And so I'm not going to be able to access it, for example, from my browser. So if I want to be able to visit the application at my browser, I need to associate it with a service. Excuse me. There's different service types. If you're going to do this in something like GKE, you would probably use a service like load balancer. But for Minikube, the common one to use is a node port that just exposes the service on the node's IP at a static port. So I defined that I want it to show up at port 30,002. So I'm naming the service Twitter search service. I'm associating it with the pod named Twitter search, and it's going to map port 80. Well, it's going to map port 30,002 on the node to port 80 in that pod. So pulling these 3 things together, I'm going to have the complete manifest that I need to deploy my application. So I define a deployment that makes sure I always have a pod up. I define the container and the environment that it needs so that it's going to be able to run. And I define a service that exposes it externally to the cluster so I can access it in the browser.
What is a node?
A node is, it's the... Oh gosh, I am not coming up with the right word for it. It's like an instance of Kubernetes cluster. So let's go back to the script that we had with the instructions and deploy the application. So I have the manifest stored as manifest.yaml. If I scroll through it, you can see all the same things that we were pulling together in the slides. And I'm going to now just type this command, which in the namespace that I defined applies that manifest. And if I look in that namespace to see what pods are available, I can see that my deployment is running in that namespace and the pod is ready. So there are some other useful ways to know about how to check the status. If I run Minikube dashboard, it'll run the Kubernetes dashboard, which is a pretty handy way of visually seeing what's going on with your application. So this is the default namespace. I need to change to the namespace I'm using. So I can see everything's green. That's good. When it's red, it's bad. The other thing that I can do is I know that I exposed it at port 30,002, and I can get the IP of the Minikube node here. And if I go to the page, it's very small, make it bigger, I can see my application is running, and it works. So it's searching Twitter right now and returning results. I don't know why I only returned one. It's maybe not a great application. But you get the idea, it's running. So let's go back to the slides. So we've deployed it in this toy environment, which is great. But that's just, playing around with it. What do we have to think about if we want to actually get this in production? So if you are deploying applications to Kubernetes at scale, some of these things I've already mentioned before, but you need some kind of a system to manage networking between microservices and ingress and egress connections that go in and out of the cluster. One of the popular systems that's coming out to handle stuff like this is called a service mesh. The one that's been really hot to talk about is Istio, but there are a lot of service meshes out there. And so it'll be interesting to see what happens in that space this year. You need a system for centralized logging and monitoring of your distributed applications. So some people I know have used Prometheus. That's a popular one, but there's a lot of options out there for that as well. And you need some kind of a way of handling persistent data and security. So Kubernetes doesn't really come secure by default. To really do things securely within this space, there's a lot of stuff that you have to do yourself. A lot of people turn to OpenShift for this reason, which is a very opinionated version of Kubernetes that handles a lot of that for you, but also can make it like slamming your head into a wall to deploy things because it does restrict a lot. There are lots of options within the Kubernetes ecosystem for taking care of these things that you need. It's possible that there are maybe too many options. This is the Cloud Native Computing Foundation's landscape. And so all of the things that you see on here, these little icons, are products that solve one of these kind of problems for you in cloud native environments and especially in Kubernetes. And they foster an ecosystem where they have projects that they give additional support to. So the blue, bigger boxes are incubating. The dark ones are graduated. So Kubernetes is a graduated CNCF project. And with all of these options, sometimes you might find that there are just a lot of competing products. So if you know you need monitoring, and you need to go find a tool to do that because it doesn't do that within the system itself, it can be really hard to make a choice. The other thing to know about Kubernetes is that it's been talked about recently as crossing the chasm. So it's moving from having primarily early adopters using it to an early majority using it, which is probably why, if you've heard a lot about it, it's moving into that phase. But that also means that some of the kinks haven't really been ironed out yet. So there are things about using it that are uncomfortable. There's not a lot of documentation on using it in practice or what a real experience of using it is. Some other things to know about. As I just mentioned, there's not a lot of guidelines for end users. If you go start looking for blog posts for using Kubernetes in practice, I feel like a lot of this stuff is still very operator focused. So you don't get a lot of, I'm a developer, how do I do this right? I do think that that is a big focus of the CNCF this year, and they're working hard to get more feedback from end users. It was one of the big criticisms I went to the big Kubernetes conference this year, KubeCon, and one of the criticisms of the conference was that there weren't enough end user stories, and people felt very strongly that the conference should be primarily about end user stories. So I really think that in this year we're going to see a lot more people using this, a lot more opinionated recommendations for ways to use it well. So that's something to keep an eye out for. I think I just mentioned this as well. Kubernetes as a system does a lot to improve the operator experience. If you talk about infrastructure as code, this goes an incredibly long way. Everything is based on the Kubernetes API. So there's a lot you can do with it. It's very flexible. You can extend it. We've done that with our project that we work on. We created a Kubernetes custom resource definition, which basically adds a resource to Kubernetes that acts like any other native Kubernetes resource, but is custom to our product. So the flexibility is great in terms of that, but if I just want to deploy an application and I don't care so much about how it runs, just that it runs, then I think that functions as a service and platforms as a service are still better at providing a really solid developer experience. One last reason for pause. You might like YAML. I just touted the benefits of infrastructure as code, and that certainly enables a lot of it, but there is so much YAML. I tweeted the other day about how to make sure my YAML works well, sometimes I actually take a straight edge and put it on my computer screen just to try to see if it's really lining up or if I did something weird, because it doesn't work if you do something weird. This is a little comic that one of my coworkers made. So it starts out with Google saying, how many layers of YAML are you on? And the person says, like, maybe 5 or 6 right now, dude. And Google says, you are like a little baby, watch this. And then they came out with Kubernetes. Is that end panel? And I also really like this one. I feel like YAML memes are my favorite, which is just indicative of the pain that I sometimes am experiencing right now with respect to it. There are tools that have been coming out to kind of try to raise the level of abstraction for Kubernetes and all this YAML. Pulumi, I think, is one of the better ones. They're providing some nice ways to be able to deploy things with kube control and have better visibility into what's happening as you do. Having said all of that, there are some good reasons to pay attention. So I went back and looked at when the major cloud providers put up their managed Kubernetes services. So Google's was the first in 2015, but it was, this part I really especially like. Amazon went GA with theirs on June 5th and Azure on June 13th. So you know people at Microsoft were flipping out on June 5th. Like, we got to get ours out now because they just did it. I've also heard really good things about DigitalOcean's managed Kubernetes. I haven't used it myself, but it seemed worth putting up there. It's still pretty new, obviously, but people are liking it. Also, the fact that it has all of those products in the ecosystem, it's very active. Many of those are open source products. So there's a really active community. Kubernetes itself is open source and has a great community governance model. I really respect the way that they've been doing things there. And the fact that there are all those projects show how much momentum it has, for now at least. There's also lots of platforms that are focusing on that really nice developer experience that are starting to deploy on top of Kubernetes. So Cloud Foundry is one. We encounter a lot of companies that we work with using some variation of Cloud Foundry. And many variations of Cloud Foundry now are built on top of Kubernetes. Pre-Kubernetes, Cloud Foundry had its own container system and runtime, and they're shifting the way that they think about it a little bit. I mentioned OpenShift. OpenShift is a proprietary version of Kubernetes that is very opinionated, but really tries to make the experience of using it nicer, with a focus on security. Then there's a couple of frameworks for doing serverless functions on Kubernetes. So if you're an organization that has some people deploying applications to Kubernetes and you want a group using serverless to use your existing infrastructure, there's now more and more tools to be able to do that. There are even people deploying VMs on Kubernetes. I was encouraging my coworkers to deploy a Windows VM using Rancher on Kubernetes just because I think that would be super funny. I don't know why you would do that, but people want to, so there it is. And I just want to emphasize, as I'm getting near the end here, there are real benefits to containers that are worth remembering. So let me just go through them again. They're easy to build in a repeatable way. You have that Dockerfile, for example, that defines exactly how it's going to be built each time. You can run them isolated from each other and from the host operating system, or you can network them together. It's actually very flexible. When you're running them, they can't see each other's processes. They have their own file systems, and you can place limits on their computational resources, so they can't just take over your system. They're portable, so you can use them across clouds and operating systems. They're lightweight, so it makes it a lot less costly to package individual microservices. And they're based on immutable images, so if you create a new image version and you deploy it and it breaks everything, you just deploy the last image version instead, and you can deal with that later. So there's something very nice about that. It's very quick to roll back. And this last bit, I know I've hit on this a lot today, but I think it's really important that it gives you that consistent environment from dev to prod. The very last thing, I kept coming up against the debate, sort of a debate between containers and serverless that's happening in the community. I saw an interesting talk that Kelsey Hightower gave where he was basically trying to build a bridge there and say, these aren't really that different. When you deploy a container, it's just an artifact that has what your code is. When you deploy a function, you're just zipping up your code. So it's a different kind of artifact, but it's still the same idea that you're creating this artifact and getting it running. So there's common ground there, and hopefully we can find it. But it seems like there's still a lot of conversations happening. Just some resources that you might use if you want to learn more. I really like this list on the top, Awesome Kubernetes, available on GitHub. She's got a lot of resources for future, any kind of learning that you want to do. The documentation on Kubernetes.io is really nice, so you can learn a lot from that. There's a cool podcast called TGI Kubernetes that Heptio was putting on. I think they still are. Kelsey Hightower has a repo called Kubernetes the Hard Way, and if you want to learn more about the internals of how Kubernetes works, which I didn't cover really very much at all in this talk, that's a great way to start from square one and deploy it yourself and learn all about that. The CNCF landscape I referenced just has a lot of projects that are out there that you might not know about. It tries to organize them logically into what their purpose is. So if you're looking for a new tool to do something, it can be a good resource to find something new. And if you want to check out the demo for yourself and try deploying it to Minikube and maybe experiment with some different things, you're welcome to do that. One last bit, CNCF also provides this trail map that is meant to help organizations become cloud native. And you can see the way they've defined it. Step 1 is containerization. So if you're already doing CI/CD and you haven't containerized, I'm sorry, you did it wrong. Because step 1 is containerization. Just kidding, you can do it however you want. But if you're looking for ideas about ways to improve your workflows, it's something that you could look at and think about some ideas for how to push your systems forward. And that's it. There is a feedback form for the conference. Since this is one of the first talks, this might be the first time that you're seeing it, but I'm sure you're going to see it a lot this weekend. My slides are also up online, so you can grab those there. Any questions? Yes?
You mentioned earlier that using Kubernetes to deploy and manage a database like Postgres is not or discouraged or not done. Can you explain a little bit more about that? And so if it's not done in Kubernetes, how would you use a Kubernetes application with the database?
So I think people are starting to do it more. It just was the case that there wasn't really a Kubernetes resource that would maintain data. So everything is meant to be pretty ephemeral. And so if you deployed a database to Kubernetes and you had it running in a container on a pod, if it died, you might lose all that data. So that's a strong motivator not to use it, right?
Sure. Yeah.
However, they came out with stateful sets sometime in the last year or two, and people have been using those at times to maintain the data or have data persistence if they deploy databases to Kubernetes. So I know that's a thing that some people are doing, but my sense from speaking with people who work on the project is that the expectation is that there's always going to be databases external to the system that your applications running within the system will need to connect to. So if you're on GKE, you might still use Cloud SQL, their managed SQL database, to actually house your data, but you'll connect to it from inside the cluster. So that kind of pattern I wouldn't expect to go away anytime soon. And I haven't read recently very deeply about it, although it's a problem that we're facing at work because we provide a product that requires a Postgres database, and people want to run it on Kubernetes, and so we're thinking about how we want to recommend they do that right now. But that's sort of my understanding of where things are at this point.
Cool. Thank you.
Yep.
The question I always have is what to use.
Yeah.
VMs, Kubernetes, the functions, or whatever you want to call it.
Yeah.
What are your thoughts about that?
I mean, I think it's like with everything else, it depends so much on your particular use case. So I have...
But imagine you can distinguish cases where one is better than the other. Could you give me an example of Kubernetes may be better?
Where Kubernetes may be better? So I think that what I've seen is that Kubernetes works very nicely if you're a big organization and you have a ton of microservices that different groups are deploying. You can use Kubernetes to make sure that there's a consistent system for deploying all of them, and that there's maybe a central team who's managing the networking between them all with something like a service mesh. So for smaller organizations, I don't know, I'm still trying to figure out what you want to do with it. I think that, yeah, I don't know how to find the path forward there. But I think that's one of those things that people are trying to figure out right now is, how do I leverage this? I mean, the best thing to me seems like if you want to do functions and you don't want to do Lambda, you could do it on Kubernetes and have a little bit more ownership of how it's done. So that's to me like the case that seems the most interesting right now if you're a smaller organization.
Goes back to the criticism of that conference, right? That they're not
Yeah.
many use cases.
Yep. Yes.
I was just going to follow up on what Roberta was saying. You know, you have that slide that showed all the different pieces, parts, and how complex it is. And it's true because Kubernetes is built so it's very pluggable, so you can use like all kinds of different things, it's not monolithic.
Yeah.
But a way to use it, there are a lot of, you showed Rancher.
Yeah.
Rancher, you can pick your orchestrator. So you can use Kubernetes as the orchestration piece, which can get you some experience with what Kubernetes does without all the complexity. There's also something called Container, Kontena, and even Docker. For years, Swarm was their thing, and they saw what was coming, and then they said, all right, we're not going to integrate Kubernetes with our orchestration too. So, it's, I've been using Kubernetes for years, and it still is like, okay, where do I go to fix this thing?
Yeah.
And it's very, very complex. So sometimes you just peel away some of the stuff you really don't need. And sometimes just go to Rancher and at least start there.
I really think that that's going to continue to happen, is that
Yeah.
people are going to build things on top of it. So it's very nice at a low level because it is so flexible and just has that modular capability where you can add all this stuff on top of it.
Yeah.
But in terms of usability for an org that doesn't have nearly unlimited resources, it really makes a difference if you can put something on top of it that takes care of more of that stuff for you.
Yeah, exactly.
Yes.
Speaking of Rancher, they dropped a something this week called K3S, which is like Kubernetes minus a bunch of things.
Yeah.
So that might be something especially if the usage is like a little, you want it really small,
Right.
and that might be interesting. Because I just deployed it on my server and it's using like a whole gig of RAM doing nothing. So I'm like,
Yeah, you have
Could you talk a little bit about the developer experience in this environment? You mentioned that this is mostly geared toward operations and deployment. But
So, interestingly,
Can you repeat
what I
the
heard
question for
from...
the recording?
What's that?
Can you repeat the question?
Oh, sure, yes. So the question was, can you speak a little bit more about the developer experience in practice using this? Because it's been more focused on operators. So I was speaking with somebody I met at a meetup from Microsoft, and they were saying that the developer experience, by and large, should still be Docker Compose. That locally, you use something simple, and then when it's time to deploy it, you're still running containers, they're still networked together, so it's still going to mimic what you're doing with Docker Compose, but the developer doesn't have to worry about the level of complexity that you see in Kubernetes. They just need to know how to write a Docker Compose.yaml. There's something really nice about that. So I haven't personally tried to work with that flow, and I'm not sure. I think there are tools that actually will translate a Docker Compose.yaml to a Kubernetes manifest. I think I've read about something like that. So there's probably stuff in that ecosystem to try to help make that smoother. But I wouldn't say it's mature enough yet to make it completely smooth. Yes?
Could you provide a little more context on this sort of anti-data bent that I'm kind of getting an impression of? Because without a lot of context, it would make it seem like this is a tool that one only uses in a larger scale to process data, but to not actually store data.
I think I can't speak to the larger trend, but I think I also have the sense that there is a larger trend for stateless applications. I don't really know where that comes from. Sure. Maybe it's a 12-factor app thing. Don't 12-factor apps recommend?
I mean, it's kind of
it's got to go somewhere. Yeah.
It's kind of, I mean, what I'm hearing is a considerable gap that people are focused on the thing that's in front of them, not thinking about, well, what does it mean to actually deploy a server that's running that Postgres database? That's a thing, you know.
Right. Yeah. Pretty common, actually.
Yeah.
I think there are also like a lot of cloud solutions just focused on the data layer.
Oh, sure.
So like RDS or Cloud SQL.
It's kind of an odd last mile thinking, I guess is my point. I'm not necessarily critiquing it entirely, but it's sort of, it's a bit myopic because you don't look at it as a system holistically. You're looking at a kidney versus a liver versus a body.
But this makes me think my boss recently, there's a law about this exact thing, that your technology will mimic your organizational hierarchy, right? So it's natural if there are groups that are focused on this one thing that they're not going to think about the bigger picture. And unless you have a group thinking about the bigger picture, nobody is.
Right.
So maybe that's the thing. Maybe we need to have a group that looks at end to end what it's like to use software in these environments.
I think part of the problem with the data layer within containers and such is you're supposed to be able to just shoot the containers and they come back up elsewhere. And because they're still living on servers. It's like we talk about the cloud. Somewhere somebody's running around plugging cables into computers, and you forget that. And so when you're orchestrating containers, like at Dockerfile, they did a demo where they brought up like 20,000 containers and killed 10,000 of them, and within a couple of minutes, Kubernetes saw that and brought them all back. But you don't know where they are on the physical server. So if you're running a container that's running MySQL, Postgres SQL, and it's got to have data somewhere, so you have it in the volume that's on the host. Well, what happens if that container gets killed and it moves to another server? Where does that data go? So there's a lot of work on volumes. You can't put it on Gluster, you can't put it on NFS, you can't put it on any kind of a normal shared file system. So I think that's why there are a lot of people who say absolutely do not do databases in containers. That being said, I do databases. But I have to be very, very careful about it. And there was a really cool project a couple years ago. I can't remember the name of it. I think it was Flock, which is unrelated to coding Flock and stuff. That's all. But it literally, you could kill a container and it magically moved the data to another server where that container came up. The project died. I don't know who took it over. Magic, it basically was just moving the data. So it took time, and that's part of the problem, is it takes that time. So if you have, like I work with some of my SQL databases where the entire thing is like 3 terabytes. That's going to take time to move to another system. So, how do you do that magically and quickly?
And stateful sets only gets you like a little piece. It's like, yay, my data will persist, but it's not doing multi-zone availability. It's not doing backups. It's not doing any of that other stuff. So
Exactly.
The stateful sets like kind of gets you there, but the managed services, like you were saying, really like you don't have to worry about those things. The managed services, like RDS, will take care of it.
Right.
Like I don't need to worry about that piece. So it makes sense. There's still some disconnect there.
So this just sounds like pay someone else.
A little bit.
And if the orchestrator is moving data from one server at the low level to another, you're still doing writes. So what's happening to your atomicity there? It's like all of a sudden this is inconsistent with here. So it's not for small ones. It's okay, but big data sets.
Maybe a healthy way to look at it is that, you work on something, you want to make incremental improvements. You start out with something that's useful for a use case. So the initial use case was stateless applications. And we're just at a point in the process where we're trying to figure out, okay, now what if I want to do something with stateful applications? Does it make sense? What is a smart way to do it? How do I handle all of these issues that come up when you try to think about that? So, be interesting to see, how do they get there? Thank you all for coming.